All right, hello everyone, this is Mr. Carson. I'm going to work out this problem right here, which is a hyperbola. If I look at it, what I notice is these coefficients are different, so it's an elliptical shape. However, one's negative, one's positive. So instead of being an elliptical shape, it's going to be a hyperbola, meaning the two parts don't come together. And it's a negative on the x-axis, so it's going to look like this. So when it's all said and done, we're going to have the two pieces of the ellipse, but they're going in different directions is the way I think of it. So we have to come up with this graph. So here we go. Step one's always completed in the square. I'm going to get my x's set. That's a negative 4x squared and 16x here. And if I factor out a negative 4, it's a negative 4x. Let me leave room to complete the square. And I always go back and check this. Let's distribute this. Negative 4 times that is that, and negative 4 times negative 4 is that. Good. Let's deal with the y's. So now I have a 9 y squared, and if I factor out a 9 from there, that'd be 2y. Leave room to complete the square, and let's put this over on this side, so that would be a 43. Now let me double check the y's. 9 times y is 9y squared. 9 times that is 2y. Good. And now let's complete the square. So what number goes in here? And that's b divided by 2 squared. 4 divided by 2 is negative 2 squared is positive, whoops, not positive 2, positive 4. And if I add 4 here, I add 4 here, but again, I'm not, there's a 4 right here, I'm not adding 4, I'm doing 4 groups of 4, and it's not adding, it's a negative 4 groups of 4, so it's a minus 16 here. It's a little bit tricky the first time you do it. And over here, 2 divided by 2 is 1, 1 squared is 1. I'm adding on 9, 1, so I'm adding on 9. And let's complete this square, and it's always x minus b divided by 2, so divide that by 2, and that's back to 2, and put the square there. So I have a negative 4 plus 9y plus 1 squared, and then on your calculator, 41 minus 16 plus 9 is 36. Standard form, divide this over, is 1, and that would be a what? Negative x minus 2. 4 divided by 36, that's 9 in the denominator. And here, divide this by 36, and that would be 4 in the denominator. So there's my equation, and that's going to help me build my hyperbola. The center, I always want to talk about the center, and the center is 2, 1. So 2, 1. Whoops, negative 1. So there's my center, and I always put a star right there. And then now on the x-axis, it's 3. So 1, 2, 3. And 1, 2, 3 this way. And on the y-axis, it's 2, 1, 2. And 1, 2. And I always, whoops, gotta go down 2. And we're not making an ellipse, but this box is still here. This box that around the ellipse, that would be around the ellipse, is still in my hyperbola. And the way I always remember it is we have these axes that go through these corners. So there's one corner, and through these corners, it's through here, and there's that corner. So that's going to help me define where these arcs go. Well, last thing I need to know is, let's see here, where are the vertices and the foci? Well, the foci here are going to be a squared plus b squared equals c squared, back to our Pythagorean theorem. And so I have 9 plus 4 because these are already squared, and c squared is 13, so c is root 13. And now what we got to do is move root 13 from the center for the foci. But the question is, well, which way is it going? And I just remember that a negative means it's not on the x-axis. So it's not on the x-axis, it's on the y-axis. So these are my vertices. I know that's a little bit backwards, but these are my vertices, and that point is 2, 1. And this other point is 2, negative 3. Now the vertices here are on the short side, and that's different from an ellipse, but this is a different graph. So now I know the direction. It's not on the x, so it's going this way, and it keeps getting closer to these lines are asymptotes, so I didn't do a good job drawing it, but they keep getting closer and closer to that. So I always like to go over it with a highlighter so we can see, and there's my graph. And it curves down this way, and it curves this way. Last thing we need to put in here is the foci, and we've already found that distance, so it moves up root 13. Well, what is root 13? Let's see here, square root of 13. It moves 3.6 spaces. Put that down here. So from the center, it goes up 1, 2, 3.6. From the center, 1, 2, 3.6, and those are your foci. If we want to write them, how would we write them? Let's see here. The foci points are over to 2, and then I'm starting at -1, but I'm adding on root 13. And this bottom one is 2, starting at -1, but I'm going down root 13. So those are those 2 points right there. And if you want to get an estimated value, let's see here. 2 when I was at -1, and I went up root 13. So it's at 2.6. Let me just check this out. Here's 0, 1, 2, 2.6. And down here I'm at -1 minus root 13. And that's 2, -4.6. Now let's check that out. Here's 0, 1, 2, 3, 4.6. And those are the estimated values there. Those are the exact, and they're there. Things to remember, this formula here, negative means it's not on that axis, and you just move up or down for here. And it's a little different here. The vertices are the points here. It's not the longer side. On an ellipse, these would be the vertices. But if I take this and put this negative over here, now the hyperbola is out there. So it just depends on where it is on a hyperbola. All right, hope this helps. You graph hyperbolas.